I'm starting it again. We're going. All right. So, examples of even and odd functions. If I was to give you this function, and I'm going to ask you, is it even, odd, or neither? Because lots of them are neither. Lots of them are neither even or odd. Attention. 7, either get off the floor or stop talking. Okay. So, when you test for even and odd functions, by the way, I need to make this statement. As far as your homework goes, if you want homework credit for this, I need to see what you got when you subbed it in. You're not just going to write me yes, no, yes, no, yes, no to get homework credit. You have to show me what you got. Okay, same here. You have to do something, yes. Okay. So on these, since they both required you to sub in negative x, I better see what did you get when you subbed in negative x. Now, you will get faster at this once you see the patterns. What's going to happen when I take it to the 6th power? It's going to be positive, isn't it? And here, when I square that x, it's going to stay positive, so I'm going to keep a negative 2x squared. Okay, so did I get the same function back? That's the same exact thing, isn't it? So, therefore, it's what? Even. It is even. This is some advanced algebra skills in graphing. Okay, so what I'm trying to lead you all to is some assumptions that are good or bad to make. Okay, because some people look at this and go, oh, look, all the powers were even, therefore it was an even function. So has this one got all odd powers? Is it going to be an odd function?
Not necessarily. You're probably not trying to make this probably right now.
Would I do that? Trick you? Okay, so I'm subbing in negative x, which means right here when I go minus, it's minus a negative x. Now, simplify that. What will you get? I'll get a negative x cubed, a plus x, and a plus 1. Okay. Is that the original function I started with? No, definitely not. So it's not even. Okay, to check for odd, it has to be a negative of the original function. So you have to try to pull a negative out front and see what you get. If you pull a negative out of that, it'll become x cubed minus x minus 1. The x's are right. They're back to the original. But the negative 1 blew you up. It didn't work. So, yep, it is neither one. Neither, neither, whichever you prefer.
Are we done?
Nope, I need to show you a tricky one. Fractions are where you need to beware.
What? Fractions? No, we're out of that.
We're never out of fractions. Never, ever, ever. Okay, so I want to do even, odd, or neither. I'm substituting in negative x. And here, now that we're beginning to get the handle on it, you may shortcut this far. What's going to happen when I put a negative in the top? It's going to be negative 4x. What's going to happen when I put negative in the bottom? I'm going to square it. It's going to say positive 3x squared minus 5. So that's really all I need to see. If you can do it in your head and simplify it, that's fine. Okay. So my question to you is it even? Is it the same thing we started with? No. Okay, for it to be odd, I have to be able to put a negative out front and have the original thing back. This is a fraction. And this is where you have to remember the special situation of fractions. On a fraction, you can put the negative on the top. You put the negative on the bottom, or you put it out front, and it's all the same value. So you get to choose on a fraction where you put your negative. So where would I maybe want to put this negative up top? If I would put that out front, then I'll have 4x over 3x squared minus 5, won't I? So therefore I have a negative of my original function. So that's odd. So I can pull the negative out front and have the same thing I started with. Okay, now, I only have 7 minutes to teach you how to do a piecewise function.
Oh, man.
No, 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 no. We can't get behind. Actually, this is mostly just graphing what you did today. It's just more than one graph, more than one shape on a graph paper. Okay, so can I switch that?
Yeah. Time flies when you're having
Yes,
fun,
this is
right,
your
Miss
graph.
Meyer?
Absolutely.
No, that's a false statement. It goes the same exact time.
I am about to show you how to graph what's called a, I should write that. No, it's actually not hard.
Are we supposed to take two pieces of graph paper?
Well, if you want one for notes and one for homework.
Lord, help me.
Okay, this is a piecewise function. We talked about them. They're on your test. Hands off, sit.
I'm gonna make them quiet for you.
No, you'll cause more trouble. Sit.
Okay. Cody, I'll talk to you after class.
Okay, so here's your piecewise function. You got -3 times the absolute value of, why did I change that?
Yeah.
Well, I'm taking it back where it should be. Plus 2. Baloney. This is not that hard.
With cheese and bread.
Wouldn't you like to know? Well,
Okay, these are all common functions you just graphed on your assignment that we just practiced with our scrambled up cards. You just took a quiz on it.
didn't we already do this?
Okay, you've done these functions as far as putting it. On your last test, I just had you do f of 2 or f of 5 from here, and you had to figure out which piece of the function to use. Okay, now I want you to graph it. Literally, this is going to be a graph. It's going to have, this first piece is what shape? An absolute value is a v. Okay, then it's going to have a cube root on it, which is a sideways parabola. And then it's got an x cubed on it, which is a regular vertical parabola. Okay, it's going to have a little piece of each of those in there.
Oh, yeah.
What you have to be careful of is these boundary lines out here. These inequalities tell you where each graph can exist. So this absolute value can only exist, it says x is less than -2. You can only graph this on the left side of -2. Then you stop it. The cube root can only be between -2 and 7. The x cubed can only be on numbers greater than 7. So until you get used to this, you don't have to do it, but my recommendation to you right now is put boundary lines on your graph paper. Where is this going to change at? It's going to change, the graph's going to change at -2 and +7, isn't it? So I recommend that you go put a little dotted line. This is not an asymptote, it's just a barrier line. Put yourself a dotted line at -2 and 7. The numbers out here that tell you where the functions change. Okay, so this first piece can only be graphed left of -2. Okay, so, Devin, where will this first piece shift to? This, yeah, the absolute value, where's it going to shift to?
Count two left, right.
That will be
Left, right,
left 5 up 2. So left 5 up 2 is right there.
I don't do miracle marijuana.
Okay. It is a, what shape? It's a V, and what's the -3 going to do to it? It's our V upside down with a slope of, it's a Christmas tree, yes. Slope of 3, so you're going to go down 3 over 1 both directions. This is a steep Christmas tree. Down, keep going down 3 over 1. On the left side of it, you just keep going forever. But on the right side, Down 3/1 hits my boundary. That's where it will stop. Now, you will have to decide, is it an open or closed circle?
Open.
There's no equal sign, so it's open. So when it hits that boundary line, it's open. So we have a V that goes that far, and then it's just going to stop dead. The absolute value quits right there. Done. Okay, then you go do the next piece. The piece in the middle shifts where?
Up one.
It's up one and left one. So from the original origin, it's up one, left one. So there's the center of our sideways scrabbler. Okay, sideways scrabblers, plot 0, 1, 2 on the right-hand side is the roots, and we have cube numbers on the left, 0, 1, 8. Okay, so I'm going to have 1, 1, and I'm hitting the boundary line. But this has got an equal sign, so I can close that one in. I'm going to go 1, 1 to the right, and then I got to go 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2. Oh, look at that. It hits perfect on that boundary line. That,
You just look at it.
that wasn't a bit planned.
Yeah, it was, you did it.
I'll do marijuana.
Okay, and so,
Why do you keep talking about doing drugs, Cody?
okay. So now, there's that piece. It stops. Notice, they don't have to connect. They can connect, but they don't have to connect. So there's not a requirement that they connect here. It's just got to be, you can't have two closed.
Are we not gonna draw the right of it?
And so then the third one, you would go right 8 up 1. It would sit right there, and you'll get, I'll put it on here, but you'll get a Scrabble going 1, 1. Oh, it's negative, sorry, it's going down. 1, 1, 2, 8. 2, 3, 4, 5, 6, 7.
Do my computer instead of.
Yep, absolutely fine.
Oh, buddy, I'll be back. I'll be back in time to pick up all my stuff.
You'll be back to pick up your stuff. Okay.
It's still recording, by the way.
Thank you.